All right, so what we're going to do is we are going to classify different shapes, okay? So we're going to use slopes and we're going to use length basically. So you do have to remember some properties. So when you, even in chemistry, when you're trying to prove something using math, it's called being analytic or analytical. So we've already done slope, we've already done lengths. Sometimes you can need midpoint. Now, if you did all the questions from the other sections, you've already done some of these where you had to prove the diagonals were the midpoints and stuff like that. So there's a variety of different kinds of questions. So these questions aren't particularly very difficult. There's just a lot of steps. If you have a triangle, you have to do 3 lengths. If you have a quadrilateral, you have to do 4 sides and 4 slopes. Okay, so that's a lot of math work. And you do have to remember some things from grade 9. Okay, so if you have parallel lines, what happens to their slopes? Philip, put that away. The line's parallel. What's yes? I'm Kylie. Sorry. Good. If you have a parallel line, the slope is equal, perpendicular, or lines that are a 90-degree angle. Yes. Yes. So some people will say flip and change the sign. The technical term is they're negative reciprocals. And then for yourself, if you want to, we're going to need lengths as well. Okay, so if you want to rewrite the formula here, okay, so let's go through the shapes. So we'll do triangles first. Each triangle has 3 sides, but it depends on how many equal sides. So equilateral, these dash marks are all the same, so they have 3 equal sides, or all of them. Isosceles has 2. Scalene has 0. So we already did this kind of question, right, where we had to find the lengths. That was easy. And then just in case the question asks you about area, So if the question asks you to prove it's a whatever, rhombus, whatever, it's not so bad. When they try to throw in area, sometimes that's like the extra little application part to it, okay? But if you were asked to find area, then you would be given the formula. You don't have to memorize that either. Okay, so the next chart is going to go through the quadrilaterals. So really, we're looking for what makes the quadrilateral unique, okay, to compare to the other ones. So we have 4 choices. It's either a parallelogram, a rectangle, a rhombus, or a square. So this little square here, that means perpendicular, okay? If you want, if this is ugly to you, like draw, we're going to separate them. You don't have to draw that in. You don't, but if that's going to bug you and you want to separate it further. So or you could use the side of your calculator as a ruler. So the sides are indicated by the lines. This tells you whether it's parallel, okay? Now, if a question, say you're asked to draw it, those marks aren't going to be on there. So a parallelogram has, it is unique because the opposite side lengths are equal. So those are opposites, okay? And then these ones. So if you are asked if it's a quadrilateral, then you have to calculate 4 side lengths, okay? In a rectangle, it's the same. So you can see that that is not unique. So that's why we also have to do slope, okay? Because the parallelogram, the opposites are not perpendicular to each other, whereas the rectangle is. So then their slope should be negative reciprocals or flip, okay? So that's why it matters whether there is parallel sides and whether there is perpendicular sides. So a rhombus and a square, they are similar because all sides are equal. So that distinguishes them from these, but then again, a square will have opposite perpendicular slopes, whereas a rhombus won't. So in a parallelogram, the opposite sides are also parallel. Same with the rhombus. But then there's no perpendicular opposite sides, whereas the rectangle and the square will. So there's a variety of ways to do this, because when you get to squares and rectangles in grade 9, you might have made those two right angle triangles, so you can use Pythagorean theorem. But we're going to try to use grade 10 like length formula just so you get more review with that, okay? So I could write a tiny little yes in here. Yes, there are parallel sides, but that's not unique. So we'll keep this like this, okay? And then, like I said, just in case you're asked about perimeter, since you have two equal side lengths and two widths are the same, and then in squares and rhombuses, all four sides are the same. So you just multiply by 4, add them together, same thing. 90 degrees, like this. Yes. So that's actually a good question. So you're looking for, when you have this line should be perpendicular to this line or this line, right? Actually, I'll just draw it once. So maybe you drew a symbol like that, like this. Oops. To mean perpendicular? Yes? In grade 9? That's fine too, you can do that. Okay, so usually you're going to get a grid and you're going to draw it, okay, which again you'll get marks for. So a surveyor has marked the corners of a lot where a building is going to be constructed. The corners have coordinates -5, 5, etc. So plot the points first. Now be careful. This graph goes up by 5s, okay? Yes. Oh, yes, sorry. Thank you. Okay, so let's say you are not a good estimator. That's the advantage of analytical geometry, because we don't want to just estimate. Is this a rhombus? Is this a parallelogram? We're going to prove it using math, okay? So if it was a rhombus, all sides are equal. And the opposite sides are parallel. Versus a parallelogram. The difference would be that 2 of the sides are the same and 2 of the sides are not. So even if you're stressed about what's the opposite sides, you're either going to get all the side lengths the same, or 2 of them will be the same and the other 2 won't be, okay? I'm not going to try to give you some kind of trick shape. So you're basically going to find 4 lengths and 4 slopes. So it also wants us to do perimeter. So once we do the length work, perimeter is not too hard, okay? But we have to do the lengths first. So these boxes are organized to kind of do both for each, like length, slope, length, slope, length, slope, length, slope, okay? I am not going to write the length and slope formula every single time. I'll just write the general one here. And then usually we do alphabetical order. So, boys, please, P, if it's PQ, then P is X1, Y1, and Q is X2, Y2, etc. Okay? So then QR, RS, PS. You can use your diagram if you prefer, and you can do like the change in Y and change in X to get length. You can do Pythagorean theorem. But like I said, I'm gonna stick with the grade 10 math. It doesn't matter what you do first, whether you do length or slope first. Sorry, I'm switching. So negative 30 plus 5, negative 25. You can show less work, okay? If you have a good relationship with your calculator, you can definitely show less work than that. So now we have slope. So this maybe is where you might want to label. Yes. You will make less mistakes. So yes, maybe, but no. So now you can decide if you want to make that a decimal. We should really, if you're going to leave it a fraction, you should reduce it. But you can certainly change that into a decimal too. But because we have to flip it to see if it's perpendicular, then maybe leaving it as a fraction, similar with what you would have done when you're graphing a line. Sometimes just leaving slope as a fraction is actually a little bit more straightforward, okay? Okay, so then just keep going. You're doing the same thing basically over and over again. I'm not going to write length because I don't want to squish anymore, okay? Sorry. Maybe I'll write L. So now we're doing Q and R. Now, does it make sense that this looks like this? Yes, right? So now, like Izzy said, can I show less work? Yes. Now, this is as long as you trust yourself up here, this is going to be 625, 15 squared is going to be 225. You're going to get 850, right? So you can, okay? If you don't want to do that because you don't trust your math, you don't trust your calculator or whatever, then just do it over and over again every time, okay? This is all the same what we've been doing, so it's not like it's new math. It's just you have to make sure you do 4 lengths and 4 slopes if it's a quadrilateral. Some people even when you guys might even go one step further and do like the opposite sides together and then do the opposite sides together because maybe it's not clear that these are opposite sides, so they have equal slopes and so are these. So not this question is not difficult. However, if you want to get full marks, you would have to do like 1, 2, 3, 4, 5, 6, 7, 8, right? Like big, lots of math. Yes. Here, 25. Thank you. Sorry, I mean. Usually you have to draw a picture so you could go back and see. If you look at the picture, then it's more obvious that Q and R and P and S are opposite. So if you want if you're like a color person, you want to highlight. So PQ and if you go back here, like PQ and RS are opposite sides. PQ, RS. So that's what you're comparing. But you still want to make sure that you answer the question. Okay. So PQ and RS are opposite. Their slope is PQRS is negative 3.5, and then QR and PS are opposite, and their slope is equal. So opposite sides are parallel. They have the same slope. All the side lengths are equal. 29.1. So if they have parallel sides, but all the side lengths are equal, that is what distinguishes it from a parallelogram. So it's a rhombus. Yes. Here. Oh, it should be, sorry, therefore. Therefore? Just like when you can write the word, just it's a symbol to, shorten how much you have to write for your answer statement. Okay, just make sure you do everything the question asks. So it wants us to do perimeter. So if all the side lengths are equal, then you just have to multiply by 4. and it was meters. Who was that? Mr. Devine, how are you? Oh, yeah. I forgot to get them out for you. The top drawer on the right under the scale. So for the next question, there's, you guys can write like in the whole bottom. You don't need to leave the right-hand side blank, okay? So just keep going on the other side if you want. We're going to do a triangle question. Pardon? Okay, we good? No problem. Did you get enough? Oh, return. Oh, good. Okay, so now Tony is constructing a patterned concrete patio that is in the shape of an isosceles triangle as requested by his client. So sometimes the question will tell you what kind of shape it is. You just have to prove it. On his plan, the vertices or the points in the triangle are P, Q, and R. If the grid is hard for you to see, each line is meant to be one, okay? 1 unit this time. Oops. So in this case, when it's telling you it's an isosceles triangle, which sides are we trying to show are equal? So you can kind of streamline the work you have to do. We need to show that PR and PQ are equal. Obviously, this is not going to be the same length, okay? So you don't have to do that one when it tells you what kind of shape it is, okay? Now, however, in order to do area, which it says next, you need the base. So we're eventually going to have to do QR anyways. But for now, let's just do these two. Okay, so this question's a little bit more straightforward because they've told us it's isosceles. So if we get 6.7 here, then you know that you should get 6.7 here. Okay, so you kind of know what you're looking for. I'm not going to rewrite this. Okay, I'm just going to plug in the numbers. Sorry, yep. But we want to be good mathematicians, right? So make sure that you've answered the question. So yes, the math has shown that, but you want to say, therefore, the two side lengths are equal. It is an isosceles triangle. And I don't know how to spell it. Okay, so B is a little bit ruthless. Okay, B asks for area. Okay, but it's good practice for all what we've done so far. So when you do the base, that's easy. We can find the length of QR just like we just did. But you have to remember a few things about an isosceles triangle. So if these two side lengths are equal, and we're going to draw in a height, when you draw, well, you'll have to remember this from grade 9. If you draw a height in for an isosceles triangle, it's going to hit exactly halfway in the base. And we just learned today, what's the point that's halfway? What do we call it? Midpoint. Okay? So draw your height in. When you do height in a triangle, it should be 90 degrees. Not that we necessarily need that, except if you want your picture to look as good as possible. Okay? Okay, so we need the length of QR. Remember, you guys, I want to try to stay on this page. You guys have that whole space down there. You can just keep going, okay? On your paper. So we need the length of the base. The base should be the smallest, right? So make sure it's the smallest length. Okay, so we can find the midpoint. We know what P is. We could determine its length. You could do that. You can also make this a little bit easier for yourself. How long is PR? 6.7. PR is the hypotenuse. If it's an isosceles triangle and the height meets at the base, how long, meets the midpoint of the base, and the base is 4.2, how long is this line? 2.1. So we can solve for this length, okay, using Pythagorean theorem. So there's really two ways to do it. Because I'm running out of room, I'm going to sneak in the Pythagorean theorem, okay? So the only thing is you're going to be this side here is the hypotenuse, okay? So we have 6.7 squared is 2.1 squared plus whatever. You can call it h squared. It doesn't matter. But you can also use the midpoint formula, find the coordinates, and then do length like this as well, okay? 6.7 squared is, actually, so now we have base, we have height, we can find area, okay? So I'm going to sneak it back up here, but you guys fill in your space. Oh, it doesn't really give units, does it? Okay, so the change you have to make down here, you're only doing 4A. The rest of 4 talks about perpendicular bisector, median. That's what we're going to do after, like, not part of the part 1 test, okay? Or quest, not a test. Okay, so remember tonight, okay, those of you that aren't done, I'll go back just 1 second. So you can either go to you can look over here, and this tells you what you're supposed to do, finish work from lessons from today. If you don't have a lot of time tomorrow night, we are going to do tomorrow afternoon, we are going to do, like, you're going to have time in class to do review. However, if you have lots of time tonight and you want to get it started, you can do that. If you're missing the homework, then it's in the chart, okay? So these are the questions that were in the notes, and the ones that I fixed. It's all fixed on here. Okay. You can look at the graph paper test formulas. There is a practice test. Here's the solutions for that. Also, I was so good. I almost got all the way through. There are also video lessons. So I recorded what we did. You can rewatch those, except for circle, I'm sorry. Okay, and I'll put this one up as soon as I'm done talking. Okay, so there's lots for you to do. Now, if you want to wait and do more of the review tomorrow night, maybe you have more time tomorrow night, that's totally fine. Okay, but the expectation is that you're working on or have completed the homework from the lessons today. Now you have like almost 50 minutes-ish right now. Okay, so you can work on that, please.